So here we will do some applications of trigonometry. In triangle geometry. We will start with the most basic thing. Okay? Start with the sine law. I will try to do it in a crisp way, so and you have to put in the work later and get more out of it. Okay. Yes. So the sine law. What is this? This is basically, in a way, it is a good tool to connect the sides and angles of a triangle. Okay. Maybe I will mention. Okay, I'll not mention. I'll ask. If I say, obviously you will know the law as a theorem. And also C by sine C that follows. But let's write the full thing. It looks good. So intuitively, or maybe I should say qualitatively, can anyone of you tell why does it make sense? Qualitatively, why does this make sense? Hmm? Think about this. This is a homework, okay? Find a qualitative explanation. These things are, in my experience, these have been useful for me to develop intuition in mathematics. And okay, think about it. Find a qualitative explanation. But let us prove this. Okay. So, any ideas how we can prove such a statement? Let us say we focus on proving this. So you see, A is on this side and sine A, that angle sine A is on the opposite side. Maybe that is a little strange. Okay, so I ask a few questions. I know that if you just sit with it and try, it will come. So the point is not to be able to prove this. We can all prove this. Okay, you drop some perpendiculars, it will come eventually. Okay, let me ask a few questions and try to answer this. Can you interpret this as a length? What is this length in the triangle? A times sine B. Like by definition of sine, what is it? What is A times sine B? Is it not the length of the perpendicular from C? From the very definition of sine.
Yes. Yes.
Good. Right? Now you know the problem is done. I don't need to say anything more. This is also b by sine. You can prove this in many ways. This is one proof. And the other side, other equalities, you can prove in the same way. However, you see, this a by sine a, we were not able to find an interpretation for that. We somehow moved the sine b that side and we found an interpretation, right? Can we directly find an interpretation for a by sine a? And it is very useful. In fact, that was the key to one of the IOQM questions, that it is equal to something. We will see. I think I also wrote it last day, so if you might remember it. But let me draw the picture and then I'll ask you to think. Draw a circle by hand. So always the circumcircle maybe should be drawn first, because then you have the freedom to draw many triangles. Any triangle you can draw. Once you draw the triangle, there is a unique circumcircle. Now, our goal is to find an interpretation for a by sine a. Okay, finding the geometric. So all these things like finding the geometric interpretation of this, finding these are actually problem solving, like going towards problem solving. These are not direct applications, but reverse thinking, inverse thinking. Right. Yeah. So a by sine a, we will try to find an interpretation for that. Okay. Like what I'm trying to say more is that without all this, we would like to understand why this is a constant and what is that constant, like in physics. Yeah. So we would like to have a triangle. This is how I think, so I'm just telling you. We would like to have a triangle where A is the perpendicular, right? And maybe, well, if you can make a triangle where A is perpendicular and sine A is hypotenuse, that is best. If you can make such a triangle. So think, like I've already drawn the circumcircle. So see if you can do it.
Sir, if BAC is 90, then won't BC be the diameter?
If BAC is 90, yes, if BAC is 90, then BC is the diameter. That's perfect. So then what happens? Yeah, so in that case, what do we get? In that case, we get that A is equal to BC, which we already know, right? In that case, we don't really get anything. A by sine A is equal to BC, but sine A is 1. So let us see. If A is one of those angles, so this is slightly new construction, so it's fine if you cannot think of it. And the question is also not very clear so far. So draw this. Okay, I join that diameter. I want to have this A as the perpendicular of something. This is 90 degree, fine. Now what can you tell? Like anything about the angles, maybe. What is BDC?
BAC.
BSc. So this is also A. I mean, I'm writing it here. I understand it's a little wrong, but you understand why I'm doing this. I mean, so yeah, so that sine A, that should be BAC, but we understand when we write A there, it means BAC. So are we done? Okay. This is A, and this DC is actually 2 times the radius. And so A by sine A, or A by 2R is sine A. So A by sine A is 2 times the radius. But 2 times the radius is doesn't see A as anything special, right? So it will also be equal to B by sine B and C by sine C. Right? So it's like a constant. That's a constant for whom? So for R, imagine you are R. For you, A is not more special than B, right? In an arbitrary setting. So we are done. Obviously, you should work out it in detail in the sense, try to yourself prove B by sine B is 2R. Right? Draw your own picture. And so this. Okay. Now you open any book from NCRT to anything, geometry book with properties of triangles chapter such, you will find many applications of this. Okay. So I again want you to practice the basic ones first, where you develop the algebra side of this. Okay. So this is one of the basic laws. Yeah. Let us quickly now prove the other law, the cosine law. Okay. So I'm giving you the foundations, and then you have to work from there. Okay. And then we will go to next level from there next time. So this is okay. Yeah, let me not talk about applications now. Let's go to the cosine law. The cosine law is like the Pythagoras theorem. Okay. So see, I'm trying to tell you that all these theorems are very easy to prove. You may not find the easiest proof yourself. Your proof may be messy, but the proofs of all these things are easy. And it's never a waste of time to prove these things. Never ever. Okay, even what we study now, like say in a master's course, the intuition for these things, are still very, very useful. Like we see some formula in some n-dimensional space and we say, this looks like a cosine law. So certain thing which was true for the cosine law should be true here. Okay. And that happens to be true. Or the proof maybe is different because of the different theory, but the resemblance, tells us what could be true. So it's always a good idea to, and you will see this will be used in complex numbers, when you do vectors, inner scalar products, inequalities, Cauchy-Schwarz inequality, these things are always will be useful because these are so concrete. Okay, so try to prove this yourselves, even though I'm proving it once, but or practice as many problems as you can. That's another way to learn it, right? So this, and we just want to, let's say, find the length of BC. Okay, so let's use the mature. So from now, let me not label the side length. So it's a convention. Opposite to the angle A, the side is called small a. That's a very good convention, right? That's a way to sort of uniquely understand what is A, B, and C. So I'll not write that. It is just A square, B square plus C square. This is the Pythagoras, so it's more, but this is the Pythagoras theorem. Okay. But if A is not 90 degrees, then we need some adjustments. Okay, so this is more than the Pythagoras theorem in the sense that it's for any angle, and when angle A is 90, then cos A is 0, and you get the Pythagoras theorem. Okay, obviously we never say that this is how you prove the Pythagoras theorem, because maybe to prove this you will need the Pythagoras theorem. That's a now let's just try to prove this. Okay, so let's prove it because it's a now the ideas are not different. Like you people have proved Heron's formula, right? Things like that. You start dropping perpendiculars. Just what we did in the earlier questions, right? Start dropping perpendiculars and use Pythagoras theorem. That's the thing we use in all these things to begin with. So let's say I want to I want cos A to be in the picture. So let's say I drop the perpendicular like this. Right? So let's say that this is X and this is Y. So what do I know? So this is like, the easiest case. We're sort of reducing it to the easiest case. A square is equal to Y square plus X square, right? But then this is not enough. We need to go to the other side. Y square plus, so this thing here, right? This thing is B minus X. That's equal to this AB, that is C square. What to do next? Somehow you have to bring in cos A. So let us first maybe get rid of Y. Anything you do would eventually work out, but nice. Looking at this, we want shortest route. So I'm subtracting the equations. So if I'm subtracting, I seem to be I don't want that. Anyways, let's see. 2bx. This is what I'm getting. Is it correct? Right? Or is something wrong? C square is y square plus b minus x square. A square is y square plus x square. Yeah, I should subtract. Okay. Okay, let us see. So this x is coming here, right? So yeah, maybe we'll end up getting something else, right? So we'll get, let's see what we get, right? So what is this x in terms of cosine? Yeah, you see this x is a times cosine c. Any problems, right? This x is the smaller, right? So it's, you had the a and it's times cosine of that, make it smaller, you get the x. It is the shadow of, okay, it is, and yeah, it's just this. X by a is cos c. It's just, I just have a little more familiarity, so I'm using that to get things faster. So it's just nothing. So we end up proving the other maybe thing. We did not intend to prove this, maybe. We are getting for C. Right? C square is equal to, you understand, it's analogous, right? A square plus square minus 2c. You can prove that. Maybe you should have started from that side. Okay. But please do prove the original one also later on. Okay. It's the same thing, but yeah. All right. So this is simple, right? So that's the cosine law. Okay. So now let us maybe prove the last ingredient, which I found was sort of needed. Certain areas. Okay. So here is a formula for area of the triangle. So you have triangle ABC. Okay. An area which is denoted by this, some books is denoted by this. These all mean area of ABC. This has a very interesting and very symmetric formula. ABC by 4R. You see, it's a sort of a 2-degree thing, right? There's a length cube in the numerator and there's a length in the denominator, so it's a length square. Right? So that makes sense, but we want to prove that this is indeed the formula. It's a, at least you will see it's a very crisp formula, right? If R is given to you, or if R is in the picture, the radius, it's a very tight, nice formula. So how can we prove this? So let me ask you something which might act as a bridge. Okay. Can you prove this? I mean, they're all going to be same. This should be easier. Like That's it. Like this should not require any sine law or anything. And like there is similarly, again, and so on. But this, prove one of them. So let's focus on this one. Stop triangle. So let's say you keep the B, that's the base. Then what is C sine A? It's the height. It should be the height, and you also know. Right? This is C sine A. So actually, these things are like this. It's nothing to prove once you see it. I mean, these lemmas, these are like so easy to prove, but they're extremely useful. Right? This is C sine A, and this is B, and half into base into height is area. That's it. So this formula is trivial. Now I want you to use it. So you can use this to prove this one. So let's try this. So now you should bring in the sine law, because that's maybe the bridge between R and. So I'll just write the sine law and I'll wait.
So we can write A by sine A as ABC by 2 times the area of the triangle.
A by sine A as?
ABC by 2 times the area of the triangle.
Yes, so you're using this one, right?
Yes.
Okay, then.
And that is 2R.
Right, this is 2R, and yeah, that's it. Okay. This is, yeah. So it's not hard. It's like on one level, it is just somehow eliminating, from this, somehow eliminating sine A using these equations, and you are bound to get this and nothing else. That's one. And if you see it in a more, nicely arranged way, then better maybe. But either way, you get the formula. Okay. So that's it. Maybe today I'll just keep it there, like till there. Okay. So we didn't do anything fancy. We just proved the, basic results. There are hundreds of formulas in triangle geometry, and I'm not a believer that they are all useful. Okay, that one should spend time in learning them. but just spend time as much as possible with just these things, and as many as you can prove yourself is what you'll be able to put to use, and which will what is more likely to stick. Okay, so now it's just up to you. Maybe 2 hours or at least practice the algebraic things, algebraic ideas to get used to the addition of formula, and so on. And then after that, you move to the properties of triangles. You can use practice from anywhere. Yeah, but start with basic book, school level book, and then challenges and thrills is there. And okay, all right. So then more problems will come, and then we will practice. So maybe so today is Friday. So as usual, we will have Sunday. That's fixed. Sunday we will just solve problems from these two topics. Okay, and you people have to give me problems. Okay, I hope you will. Okay, and yeah, then maybe next Friday we can go back to the IOQM geometry section. I think that is that a good idea, or do a bit more? No, let's spend the next two classes also after that. Next week also, let's spend doing geometry from this trigonometric angle. Yeah, let's get better at it. We cannot get better at it in just two classes. Maybe 4 classes, fine. Right? Yeah, then we'll be solid. So then next week, I will solve some questions from trigonometry, from some Olympiad style trigonometry questions. Okay. All right. Then see you on Sunday. Okay. Try to get some time in this. All right. Bye. Good night.
Bye, sir.
Bye.
Bye.